Welcome everyone to Unit 5 Stoichiometry, Part 2. So in this video we're going to review some stoichiometry basics, essentially define the mole for you, calculate the number of atoms, molecules, or formula units in a given amount of a substance. We're going to calculate the mass of a substance that is produced or consumed in a chemical reaction given the mass of any other species involved in a reaction. We're going to write mole ratios relating amounts of reactants and products in a chemical reaction. We're going to describe all the information described in the balanced chemical equation. And finally, we're going to balance a chemical equation when given a skeletal equation. Essentially, for your stoichiometry, just think of it as a puzzle. So you got to find the pieces to the puzzle, put the puzzle together to be able to answer the question. How I remember that is you're given, your find, and drawing a line skills. So if you're good at those, your stoichiometry should be strong. Let me show you what I mean. So what is stoichiometry? Remember, a stoichiometric problem is one that requires you to determine either the mass, the volume, the number of moles, the number of atoms of a reactant or product, doesn't matter, in a chemical reaction based on their mole ratios. So whatever the balanced chemical equation says, those are the whole number ratios that you use to compare one reactant to another reactant or one reactant to a product. Essentially, if you know the amount of one reactant in an entire chemical reaction, you can find or know the amounts of others. So, can you determine the masses of reactants or products needed in a chemical reaction just from the coefficients in a chemical equation? And again, let me be specific. Can you determine the masses of the reactants needed just from the coefficients? No. The coefficients tell you the moles, so you need masses. So what can you do? You can convert to grams. But how would you do this? You use mole ratios. So here's an example. Consider the following chemical reaction. It's a balanced chemical combustion reaction here we have with oxygen and ethane. So of course in every combustion reaction we create carbon dioxide and water. What does this mean? It means that 2 moles of ethane must have 7 moles of oxygen to fully combust and make 4 moles of carbon dioxide with 6 moles of water. But we usually don't deal in moles, we usually deal in masses. So we know how much mass of ethane we have or how much volume of ethane we have. And we want to know what volume or what mass of oxygen we need to react it with that mass of ethane. But this balanced chemical equation gives it to us in moles. So what can we do? We can convert mass to moles. But now we have a problem, right? Because now we just converted mass to moles of only methane, but I need to know how much oxygen I need to react it with this ethane. We can use this mole ratio here, 2 to 7, to find out how much oxygen we actually need. And how do we do that? Well, if we know the grams of ethane that we need, we can use that to find the grams of oxygen that we need. And we can also use that amount to find both the grams of each of these products that are going to be given when we react these two reactants here. So that's pretty cool. We can use stoichiometry and the mass of one given amount to find the masses of the other amounts, whether it's a reactant or a product. Doesn't matter. If we know one, we can get the others. So there's stoichiometry for you in a nutshell. Okay, let's go ahead and move forward and do some practice. So ratios to know and use. Remember Avogadro's number, 6.02 times 10 to the 23rd of anything, whatever you need, right? Atoms, molecules, ions, photons. It's kind of a nice trick when you want to convert moles to whatever it is you're looking for. Molar mass is a second. Remember that comes from the periodic table. So remember the mole ratio comes from the balanced chemical equation. Molarity is moles per liter. Your gases at STP at standard temperature and pressure. That's saying it's 1 mole is equivalent to 22.4 liters of a gas if that gas is at 0 degrees and 1 atm or 1 atmosphere of pressure. Remember your density units, mass per volume. which can be given as grams per milliliter, grams per centimeters cubed, or kilograms per liter. Always set up your given and your find. What are you looking for, right? Your find is what you're finding. What are you looking for? Your question mark. So always set up what you're given, what you're gonna find, and make sure that your units cancel. If you cancel your units, odds are you did the problem correctly. So let's do an example here. Remember, in chemistry, a stoichiometry problem is a simple math problem because it involves one basic series of steps. Number one, you write and balance the equation for the reaction. If you don't have a reaction, you can't do stoichiometry. You can convert from grams to moles, but that's all you can do. So convert the given masses of reactants to moles. Convert the moles of one to the moles of another. And then once you have the moles of your unknown, convert it to your mass, and then you have your final answer. So essentially, here's what it looks like. You have the mass of a given, convert it to moles of your given, take those moles of given, convert it to your moles of unknown, take your moles of unknown and convert it to your mass of unknown using your molar masses, of course. So you use your molar mass to convert from mass to moles, mole to mole ratio to convert from moles of reactants to moles of products, or moles of products and moles of reactants if you're going backwards, and then moles of unknown to mass. Your chemical reaction is going to go right here through the middle, and you can always do this roadmap is what we call it, to find the mass of a given to the mass of an unknown. And these are the basic steps always that you're going to use for any chemical equation or any chemical reaction that's given for any problem that can potentially arise. Doesn't matter what the type of problem is. If you have a chemical reaction, do these simple steps and you'll get the right answer. So let's do this first practice. Solid lithium hydroxide is used in space vehicles to remove exhaled carbon from living environment by forming a solid lithium carbonate in liquid water. What mass of gaseous carbon dioxide can be absorbed by 100 kilograms of lithium hydroxide? So remember, step one, we have to write a balanced chemical equation. Otherwise, we have no stoichiometry here. So what are our reactants and what are our products? So reactants, what's reacting? We have solid lithium hydroxide. And that's used in space vehicles to remove exhaled carbon dioxide. So here's our reactants. Reactant 1, reactant 2. Lithium hydroxide, which is LiOH, just cross R. This is ionic, so +1, -1. And carbon dioxide. So dioxide tells us that is covalent, so that's CO2. And it's forming solid lithium carbonate, so again solid. So we have a solid here. And carbon dioxide, we know hopefully by now that that's a gas. And lithium carbonate, carbonate is CO3, that's 2 negative, so that 2 is going there. And again, that's solid. So this is our product. And liquid water, we know H2O, and it's telling us it's liquid, so that's my L. So we have our 2 reactants and 2 products here. So here's our balanced chemical equation. So we're being asked to find the mass of gaseous carbon dioxide. Carbon dioxide, CO2, and we're looking for grams, question mark. That means we're looking for grams here. What mass of gaseous carbon dioxide can be absorbed by 1 kilogram of lithium hydroxide? So here's what we're given. We're given 1 kilogram of this solid here. We're looking for how many grams of carbon dioxide are going to be removed when we react it with lithium hydroxide. What do we need to do? We need to find the grams of carbon dioxide. So we're going to do our roadmap, but we can't cut across here, mass to mass. We can only cut across at the top. So when we come up top, that means we're converting our kilograms to moles. Now we can compare moles of lithium hydroxide to the amount of moles of carbon dioxide. Once we have moles of carbon dioxide, we can convert to grams. So here's our roadmap. We got 1, 2, 3, 4 stops. And that's our next step, is to draw a roadmap. 4 stops means we got 4 stops on our dimensional analysis. . 1, 2, 3, 4. Each stop goes on the top. So our first stop is 1 kilogram. And you know what? I'm just going to convert that. Before I put that in there, I'm going to convert this to grams, and then I can convert that to moles. So let's do that first. We have 1 kilogram. We're going to convert that to grams. That's what I'm given. That's what I'm looking for. Cross cancel my units. And the number 1 goes with my larger unit, 1 kilogram. And I know that for every 1 kilogram, I have 1,000 grams. So that's going to give me 1,000 grams as my new unit. Or you can just memorize 1,000 grams is in 1 kilogram. So that's 1,000 grams of lithium hydroxide. That's my first stop. My second stop is moles of the same thing, lithium hydroxide. So I'm just going to write moles of lithium hydroxide. My third stop is moles of carbon dioxide. And my fourth stop is grams of carbon dioxide. So now all I got to do is cross cancel all my units. So if I have grams of lithium hydroxide, I need grams of lithium hydroxide down here. If I have moles of lithium hydroxide, I need moles of lithium hydroxide down here. Same thing, moles of CO2, I need moles of CO2 down here. That way they all cross cancel each other. So now I can plug in my numbers. Anytime I have a mole to gram ratio, remember the number 1 goes with moles. And for every 1 mole, I have a molar mass of lithium hydroxide, which is about 23.94 grams. And now we have a mole to mole ratio. We get that from the balanced chemical equation. So moles of CO2 that were given, 1. Moles of lithium hydroxide that were given, 2. Now we have another gram to mole ratio, so we put 1 for moles of CO2, and then grams of CO2 we have 12 from carbon, 16 and 16 is 32, so we have 44 grams here. And remember, we have to multiply across the top, get a number, multiply across the bottom, get a number, and divide the two. So we get 44,000, divide that by 47.88, and we get 918.96 grams of what? We have a bunch of stuff here, right? So let's see. Grams of lithium hydroxide cancel with grams of lithium hydroxide. Moles of lithium hydroxide cancel with these moles of lithium hydroxide. Moles of CO2 cancel with moles of CO2, and we're left with grams of CO2. And there you have it. So again, using the roadmap, what we're given and what we're looking for, we're able to go up and over and compare our moles and find the moles of what we're looking for to convert it to grams. So again, using our roadmap here, we're able to set up our dimensional analysis bar, cross-cancel our units, and find our final answer. By using this method, you should be able to do pretty much any problem I throw at you. The first thing is you're going to have to annotate just like I did up here. Once you annotate closely, you'll get better and better at setting yourself up for success here. So once you get the ball rolling, it pretty much just kind of starts to snowball from there, and just it gets you to a familiar place where you can easily solve the problem. So just keep practicing. There's lots of practice on pages 5 through 7. Please complete every single one of these on pages 5 through 7. I will give you a date to have these due by, but start practicing them